All right, guten Morgen. Unfortunately, that's about all the German I speak. I'm trying to understand more now. But I live in Pennsylvania in the US, and I'm a huge fan of German engineering. I love coming out here. I think this is my third or fourth Basta. And I really appreciate the developer community that has kind of built up around Basta. So Mirko and Vanessa and everybody else here, we appreciate your hard work. And thank you for having me here. OK, let's talk about some fun stuff this morning. Real-time apps. What does it mean, and why should we do this? So before we start with .NET and SignalR, maybe let's justify a little bit as to why we are doing this. So we'll start there. So my name is Sam Basu. I am a developer advocate with Progress Software. You may know us for the things we build. That's Telerik UI for all your .NET apps, Kendo UI for all of your JavaScript and Angular and React and Vue, Sitefinity, Fiddler, productivity tools, reporting solutions. We are all for developers to be more successful. We have a booth outside, so please come and see us throughout the day. We have stickers and raffle prizes. And that is my social handle, so if you need to get hold of me on Twitter, GitHub, Skype, that's where I'm at. OK, so let's back up a little bit and talk about how we got here. Anyone know who this gentleman is? This is Sir Tim Berners-Lee. So back in 1989, this was at CERN, the particle physics laboratory in Switzerland. He was doing some experiments, and what he did was the first of two computers talking to each other in a format that is meant for the web, the web browser of that time. And that was, I mean, he started the W3C and the whole standardization process, and essentially that became HTTP. Hypertext Transfer Protocol. Now, in reality, like the networking between computers, we have had that before. United States had the armed services had a research wing called DARPANET, and they did like TCP/IP back in the 1960s. But this was when kind of the internet and HTTP started getting standardized. And a lot has changed, obviously, with the web. In 2020, we use the web ubiquitously across multiple devices. But not a whole lot actually has changed. I mean, sure, we have HTTP2. We have a lot more efficiency. We have things much more compact. But again, the fundamentals of how HTTP works hasn't really changed all that much. You have a server that's hosting some sort of an application, and you have clients. Could be web, could be desktop, could be mobile, requesting things from the server. And it's still a request and response protocol, right? And nothing wrong with that, but except we want our apps to be lightning fast. We want our apps to be quick. And this presents a bit of a challenge, right? Because it's not real time. So do we need real time? And the answer is yes. I mean, there is a whole plethora of application types which not just benefit, but they depend on things being almost real time, like stock tickers, chat applications, any type of collaboration, gaming, of course. So all of these things need us to be almost real time, but we are still stuck with HTTP. So how do we get around that? So now this is nothing new, though. We have had this problem for the last 20 years. And we have found our ways around some of the problems. But no matter what be your technology stack, .NET, JavaScript, whatever, this is hard. Because you're fundamentally running up against how the web is built with HTTP2. Different platforms have different demands. You have bandwidth limitations. The web fundamentally wants to be stateless. So if you remember a whole lot of things, your applications start slowing down. We have to be conscious about the network. So this is difficult, right? No matter how you do it. What we're looking to do is a bidirectional communication between the web server and any type of client. And they should be able to call each other seamlessly. But this is not easy, as we all know. So let's look at some solutions. Again, like I said, this is not new. So we have worked our way around some of these roadblocks. So the first thing we started doing is polling, regular polling. And I'm going to try to explain these things with a little, maybe an anecdote. So any of you have little kids at home? When you start a long drive, 5 minutes into the drive, they start asking, are we there yet? And they keep on asking, like, are we there yet? Are we there yet? Until you get to your destination, right? That's kind of what regular polling is. So you have a server, and no matter what the client is, you just keep asking the server, do you have something new? Do you have something new, right? And this goes on. And most of the time, the server says, no, I don't have anything new. And eventually, the client asks, and then there is something new. Now, this is not as bad as it sounds, because we are having unnecessary trips to the server, but most of the time, we're not carrying much data. So we're not wasting bandwidth, but this is not real time. So if anything happens like in between, the server has no way of letting the client know that something interesting happened, right? So this was the first step, but it's not the best. Then we learned that we can do better. We can do long polling. Same idea, you have a server and a client, and this is where if your child asks, are we there yet, you just don't respond, right? Until you get to your destination. So that's the same idea. So the client is going to ask, do you have something new? The server is like, no, but hold on until I have something new. Or maybe the request just times out, right? In that case, the server can give you a timeout, and it's your responsibility from the client side to reestablish that connection back up to the server and wait for it, right? Now, this is almost real time, because at any point, the server does have an open request to get back to you in terms of giving you something new as it's happening. So this is nice, but it needs a little bit of orchestration on both the server and the client side, but this is definitely nice. Then we learned to do some more tricks. And this is where we started getting into the browser wars, and things started getting a little different. This is everything but other than IE started doing this. So we have a concept of server-sent events, where the client and the server, they do a little handshake, and then it's almost like an event handler on the client side, and the server keeps sending you things down. It's like a one-way push down from the server. And this is real-time, obviously. And again, support varies a little bit by platform. We also learned to do other things like WebSockets, which is beautiful. Again, this is when HTML5 was getting finalized, and support was a little varying. But now, almost every evergreen browser will actually do this, and I'll show you this. So this is a thing where I'm going to do a cultural joke here. I'm brown. I'm from India. I live in the US. And there are parts of like Florida or California, or definitely in Mexico. When I go down there, people will come up to me and say, hola, which is hello in Mexican. And if I say hola back, then the Spanish just flies at me, and I don't understand a word of it, right? But that's exactly what's going on. So the server and the client do a quick handshake to say, do you speak my language? And if the answer is yes, then we can talk. Right? So it's complete, full bidirectional communication, full duplex between the client and the server. The client can call the server can call the client at any time, which is beautiful. And then eventually, one of them says, I'm done, and then you bail out of it. Right? So when this works, this is beautiful. This is exactly what we want. Now, along the way, there have been a few other things. When Flash was a thing, when Silverlight was a thing, we used to do socket connections over plugins, but plugins are done. We should not do plugins anymore. IE, Internet Explorer, did a thing called Forever Frame, where they would do like a hidden iframe, and there's a little bit of JavaScript, and you call up to the server, and you keep requesting information, and it works. There's a new thing called gRPC. This is from Google, but again, it's a very open standard. Protocol buffers as your transport mechanism for RPC applications. Really good for like microservices. But the point is, no matter what you are choosing, the transport layer is difficult. You have all of these various ways of doing transport, and it would be nice if somebody did that for us, right? So we don't have to write so much of custom logic to do our network, and we can focus on our application logic. So let's look at some of these frameworks that help. Like I said, gRPC, please take a look at this if you're into microservices, if you're into cloud native or similar architectures where you have different parts of your application communicating with each other in real time. This is really good. It comes down to binary serialization with some other protocols, so it's really nice. And you can actually use binary serialization with SignalR as well, which is what we're going to talk about. So let's talk about SignalR. I'm guessing most of you are .NET developers in the room? Yeah? OK. I do .NET and JavaScript, and this is actually platform agnostic fairly for different types of applications, web, desktop, and mobile. So let's start with .NET, because the only real constraint that SignalR will have is you need to build an ASP.NET application of some type and just host it somewhere. That's about the only Microsoft or .NET thing you need. Beyond that, it can be any other technology stack. So as you all know, these are Microsoft slides. .NET is evolving. It's not your old school .NET anymore. It's .NET Core, it's Mono, and things are evolving very, very fast for different types of platforms. This is .NET as we stand today. And we have a little bit of fragmentation, maybe different types of .NET. We have .NET Framework that's been around for like 17 years now. Maybe it's in maintenance mode, and it's going to be fine. Your applications are going to be fine. .NET Core is about 4 years old. It's lean, it's cross-platform, it's modular, works on Linux, works everywhere, and it's beautiful. ASP.NET Core, a lot of desktop stuff now runs on .NET Core. And then Mono, which is the port of .NET to other platforms, that's been around for 15 years as well. And that's what runs on Xamarin, which is for your cross-platform .NET apps for iOS and Android. So with all of these .NETs, you have fairly good flexibility as to which platform, which device you want to build for. Now, this is the .NET you're going to see later on this year, hopefully by October timeframe. This is .NET 5, and this is what Microsoft is working on right now. It's a big initiative. There are lots of moving pieces. Essentially, they want to have one standard .NET, and then switchable runtimes for the type of application you're building. Right? So again, the tooling for it is being built as we speak. Nothing major should change, but it's just .NET is going to be unified a lot more starting this year. So this will be fun to look into. These two gentlemen are really, really smart. This is David Fowler. He's from Barbados, and that's Damien Edwards. He's from Australia. They both work on the ASP.NET team. And this was way back, like 2012 timeframe almost, where they were trying to collaborate on some Office documents, and it just wasn't working. So they just started building an application framework on their own. And it got so good that it started getting included in the ASP.NET framework. That's where SignalR essentially first started. And then they did SignalR for about 2 to 3 years, and then they put a pause on it because they were doing .NET Core and ASP.NET Core. It wasn't the highest priority, so they put a pause on it, and then they redid it back again like 2 years back with ASP.NET Core. So these two are very smart gentlemen. They are always online trying to help out people. If you are using SignalR or anything ASP.NET, please feel free to follow them, reach out to them. So let's talk about SignalR. Like I said, all of these network protocols are there for us to use, but it's a lot of work. And essentially, these frameworks do a little abstraction, so you don't have to worry as much about the network stack, and you can focus on your application. The only thing they require you to do is to build an ASP.NET or an ASP.NET Core application, have it hosted anywhere, and that's about it, right? So SignalR is very, very powerful. It takes care of the transport layer, and it looks at the server, it looks at the client, and it figures out the best transport for the pair. And then if it doesn't work, it falls back to other things. And it uses things like WebSockets, long polling, server-sent events, all of those things. So it's a nice fallback plan. It has a very nice API, both on the server side and on the client side. And the client can really be anything, .NET, JavaScript, iOS, Android, desktop, it's all fine. And it's very scalable, as we'll look at. It supports a variety of clients. So it's very, very nice. Now, again, Microsoft slide, they are not surprised, or there's no surprises here. Microsoft is the biggest contributor to GitHub, and almost everything they do in ASP.NET, Azure, it's all open source. So again, so is SignalR on top of ASP.NET Core. You can look at the nightly builds. It's really nice, an open and rich ecosystem you're coming into. Another pop quiz. Anyone know what this is? This is Beijing International Airport, the new airport. Once all the travel stuff and the virus scares are done, we can get back to normalcy. This is the new airport that's meant to handle more traffic than, almost double the traffic than the European or the Middle Eastern hubs. But essentially, this is a classic, like a hub and spoke design. A lot of airlines actually do operate in that hub and spoke model. They like to bring you to a hub, and then they take the long-haul flights. The only reason I'm bringing this up is SignalR is very much based on that hub and spoke model. There's a concept of hubs on the server side where you have multiple clients connecting up to one hub, and that's your single source of information to keep track of all the clients, every client that's connecting up to it, and how you send messages to every client or the only one client or chosen set of clients in a group. Everything happens from the hub. And it's an in-memory object, essentially, that you create on the server side, and that has a very nice API, and you work with that. So that's the SignalR Hub, which we're going to look at. Essentially, it's middleware for ASP.NET Core. So let's kind of dive into what's happening with SignalR under the hubs. So it's the transfer protocol, like I said, it really varies based on the server and the client. And it'll do some things for you, like managing all the clients with an API, so you can keep track of them. It does user authentication, authorization. It will do logging and other things for you. And essentially, it will do serialization and deserialization. Right? We're going to start out with some like little strings, but very soon, once you start making real-world apps, you're going to want to transfer objects back and forth, right? So it'll do serialization for you. The default is JSON.NET, which is now built into .NET itself. You can choose to use, it's nice and configurable, so you can choose to use Newtonsoft JSON if you want, or you can fall back to something like MessagePack, which is what gRPC uses to do the protocol buffers. It's binary serialization, so it's a little more compact and a little more efficient than JSON. So it has all of those features, all of that configurability built in. Now, another question is, as you're building applications for web or desktop or mobile, should you reinvent the wheel, especially on the UI stack? And the answer should be no, because you are trying to ship apps quicker, and that's where there's a rich ecosystem to help you out. We are not the only ones, but we would like to think we have the best possible love and care we put into our UI. So we make Telerik for all things .NET UI, for WPF, WinForms, all things ASP.NET, web forms, MVC, lots of Blazor, Xamarin. So we're all in for .NET. And then to me, our other framework, Kendo UI, which is for JavaScript, that's a classic story of how the web has evolved. When I first started, it was a simple jQuery-based library, and now we make components for React and Angular and Vue. So again, the web has evolved to use whichever SPA framework you want, and you should be able to have good UI. And the question is, should we be able to use all of this UI with SignalR? And the answer is absolutely yes, because SignalR is just a backend. It's trying to give you all the real-time data. How you want to hook it up on the client side, that's up to you. OK, so we are 20 minutes in. Shall we look at some code? All right. Let's dive into Visual Studio. Let's see if things crash, but we'll have fun. All right. So first thing you want to do is start up here. So if you do a search, this is where you start up. And the community has really stepped up, and documentation for SignalR and SignalR Core is really, really good. Again, developers have spoken up to say this is where the pain points are, and they've fixed things. So this is really good. Start here, and they talk about the hubs. They talk about the different types of client technologies that you have. What are some APIs you can use? How do you get started, and so on. So essentially, you're going to be building an ASP.NET application. So this is where I am at. This is really just a classic ASP.NET application. Nothing else going on. This is just a Razor Pages application. If you are doing stuff on ASP.NET Core 3.0, the SignalR stuff on the server side is actually built in. You don't have to do anything, just file new project, and you have SignalR support. So we're going to start out with this thing called the hub, which is essentially our in-memory object. And we're going to start with the chat hub, because chat is like hello world, like 101 with real-time apps, and then we're going to take the next steps. So here's like one method on the server side that takes in a user and a message, and it tries to broadcast all of that to every client that is connected. So just one line of code here. On the startup, when our application starts up, this is, again, nothing different, just standard ASP.NET configuration and setup. The only one thing we're going to add is add SignalR. That's just middleware. This is for SignalR to know exactly how to get the traffic and route it to the SignalR hub as compared to the standard ASP.NET pipeline. And then you have one mapping of the route, so it knows how to route things to that particular hub in your application. So beyond that, that's all the server side. On the client side, you can do multiple things. You can get a NuGet package if you're doing JavaScript, which is what this client is. This is just web. So you can get the JavaScript client, or you can use something like Library Manager, which uses CDN. So you're serving up the JavaScript from your geographically close locations from where the users are, maybe in Australia or Asia. You want to serve up things that are close to them. So libman will actually serve it up from a CDN. And that's it. So here is a little bit of client-side code. It's just a couple of input boxes, then one button, and then we have a div tag that holds a list of messages. That's about it. So let's fire this up, and we'll see how this runs. OK, so here we have Chrome. Let's pull up Edge, which is also Chromium now. All right, we'll make this a little smaller so we can see side by side. You know where I'm going with this. All right, let's do localhost 5001. So here we have two different applications. So I can say web1 says hello. When I do a send, it shows up right here. And we can have web2 say hola, and it shows up right there. So it's real time, right? So the reason this is working is both of these two clients are connected up to the same hub. And if I go look at the code again, which is right here. We're going to stop this. And here's a little bit of JavaScript that it takes. So essentially, from the client side, this is JavaScript client. So we're connecting up to that particular hub. And then we have this send button. When you hit the send button, we capture the input and the message from the DOM. And essentially, we call this send message method, which is on the server side, which is exactly what we defined in our chat hub. It's this method. But then the server turns around and calls this method on every connected client. So every connected client needs to have this method defined. So we'll go into this method right here, and we are essentially receiving that input from the server. That's our user and message. We encode de-encode that, and we just add that to our DOM to show a list of messages, right? So just one-on-one, really basic stuff, but it works because now we have a SignalR on the server side, and we have SignalR with some JavaScript client on the client side for web applications. And this is one-on-one, but it's nice to see it work, right? So now let's take the next step here. Let's close down this one, and let's fire up another Visual Studio instance. And let's look at some other clients. Now, this one is going to be a .NET client, and I'm showing you a Xamarin application, which is cross-platform. So obviously, there is no platform-specific code in terms of iOS or Android. This is purely done in a .NET standard. So here is a very simple Xamarin Forms solution. So here is my .NET standard library, and then platform-specific things for iOS, Android, or Mac. Essentially, what we do here is get one NuGet package, which is the client-side dependency. And that is listed right down here. And it's called ASP.NET Core SignalR Client. If you're using SignalR on ASP.NET, get the corresponding ASP.NET SignalR, and stuff will just work. So here's our main page. Essentially, nothing else going on here, just two placeholders for our user and message, and then a single button. And then what we have in this main page XAML, this is .NET code. And let me make this bigger instead of zooming in and out. So essentially, this is pure .NET code. We create a connection. We are going to use that hub connection object, and we connect up to that same chat hub that's on the server side. And when you hit send, we essentially invoke the send message method that's sitting on the server side. So we essentially grab what the user is typing, and we want to send that off to the server. And when the server comes back, the receive message also needs to be defined, because this is a separate client. So we do need a string, like two pieces of strings that we're collecting back from the server, and we want to display it here. Now, this is pretty standard boilerplate .NET code. So I can do this from a console application, from WPF, WinForms, doesn't matter. It's the same .NET client that we're using. So let's fire this up again. Let's go to the web, make sure that backend is working. And now we are going to pull up the client front end. Now, this being a Xamarin application, it knows that I'm on a Mac. It knows that I have Xcode, so it knows how to do a build. And you're going to see the iOS simulator come up. OK. Now, you see, again, where I'm going with this. So the web can say hi. It shows up right here. And now we can go to our iOS or Android and say whatever, and it'll show up right there, right? So again, real-time apps between web and mobile, could be Android, could be iOS, could be really any .NET platform that you can think of. If you're building a native iOS application, there's a sort of unsupported Objective-C client as well. If you're doing native Android, there's a Java client. So again, pick up the client that you need for the type of application that you're building. So again, this is 101. So we know this works. How about something a little more fun? So let's stop this one here. And we're going to stop both of those applications and look at something else here. This one here is another page in our application. It's called the dashboard. And there's a hub that's tied to it, because I want you to envision applications where, whatever be your industry, maybe you have folks with mobile devices or tablets out on the field, and then you have the core information on a server. And wouldn't it be nice if you had connectivity, if you were able to push things from the server side in real time, and the client also being able to talk to the server in real time? So that's what we're trying to achieve here. So here's a dashboard. I have two methods here. The first one essentially is just an update. This one is dealing with a string. But this next one, I want to actually plot some data in a grid or a chart. So I have a little bit of a complex object here, just string and an integer. But again, this object can be anything custom, and it'll all work because it knows how to serialize and deserialize. And from the server side, we are expecting an array of that object, and once we receive that array, we want to send that off to every client. So here's our UI, which is not much on the web, and here's the JavaScript file here. Let me make that a little smaller, maybe. Okay, so when you hit the dash update button, essentially we are going to update just like one thing, like a gauge value. But when you hit the send object button, we are going to create that JSON object with some values, with a name value and a key value pair, and try to send that up from the server. So that's my server side. Now let's go back to our Xamarin application. The only thing we're going to do here is switch up the starting page. And we're going to go to this page, which looks a little busy, but essentially it's XAML, and it has a gauge and it has a grid, just to kind of give you a feel of a real-time dashboard that you might want to throw on an application on the client side. So if I fire this up now, you will have a similar backend, but now it's just the web client that's waiting up for us. And now let's go ahead and pick up this one here. The client side. Okay, now the one thing I wanted to do was just to kind of have a nice real-time dashboard. We wanted to have some polished UI, and I'm using Telerik UI because we have all of this UI ready for us in our Xamarin suite. So we have a dashboard, we have a chart, and let's go to that dashboard on the server side. And this gauge value essentially will control this needle. So if I do 60 to gauge update, you can see the needle move. Just to double check. So the server is getting the update, right? And on the client side, we can make a little more sense of that update. It's not just, it's a piece of string or integer, but we can actually plot some values based on what that thing is. Now, this other thing that's kind of looking a little squished, but this is essentially a grid inside of a mobile app, and it's plotting A and B and 20 and 30. But if you notice, back in our hub on the client side, we were sending up values like 5 and 10. So if I do that from the hub, if I hit this grid update, you're going to see this value change to 5 and 10, right? So again, super simple example, but just to kind of get you guys a little thinking that you can build client-side application with iOS, with Android, and have a dashboard that is real-time, and you can do server-side push from the dashboard. All right, so I have 10 minutes left. Let me stop, and then I'm going to show you more things here. One other thing I might want to show you is one other solution, just to kind of show you the flexibility. If I changed up one line of code in here, this one here has that add MessagePack protocol. So this one line of code says, don't use JSON, use binary. Because this was in Chrome. If we pulled up our Chrome DevTools, you're going to see WebSockets connection. If you did this, then it's going to do binary over the wire. So you really cannot read any of that. And then take a look at the chat hub here. When I say clients.caller, I can refer to the individual caller who pinged me. When every client comes up to the hub and joins, we can put them in a group. So we can have like a chat room, and we can name a chat room. We can reach out to everybody inside of a chat room, like this one here, clients.group. So only people who are in that group will get this message and nobody else. So you have a lot of controls, a lot of kind of modular control over how you connect up to every client. So I'm not going to pull this up for the sake of time, but you get the idea. Let's go back and let's talk about some more things here. So we talked about SignalR, just the core basics of it, but there are more considerations as you build real-time apps for production. You would want authentication, you would want authorization, you would want logging, you would want a whole bunch of security, other things. So all of that is baked in. This is part of ASP.NET. So this is really no different compared to any other ASP.NET application in terms of authentication, authorization, and all of those things are stacked as middleware before you get to the SignalR hub, right? So anything you can do with an ASP.NET application, you can do it here. It will do logging, and it'll do security. There's a way to stream data. If you have packet sizes, then you can keep pushing from the client side. So a lot of configuration that is kind of built into SignalR, and it's really nice. I have other demos where I have a SignalR hub, and I'm connecting up to a WPF app, or I'm connecting up to a HoloLens app. All of this works because the client side is really flexible. Another consideration is how do you scale? One of the things we didn't talk about is the hub being a server-side in-memory object. That's fine if you have a single server. The moment you have a server farm, or you put this behind like a data balancing thing, things get a little tricky because every server is essentially going to have a hub, and it's not going to know the other clients that are on the other server, right? Because it's in memory. So how do we get around that? There are many, many options. You can write things to a SQL server if you need to, but you want things to be a little fast. So another very good option is Redis, which is, again, an in-memory database. You want to have this on a piece of hardware that is accessible from every server. And then as you connect to hub on this server, it writes to that Redis backplane. And then you know. When you say clients.all and send, it knows every client, not just the clients connected to one server, but every server, right? So we just have to scale out, keeping in mind that we need something that's outside of just one server. So there are options here, but you can also let Microsoft do some of that for you. Azure is a gigantic cloud infrastructure, does everything under the sun. And one thing they have that's really nice is an Azure SignalR Service. This is for you to host your SignalR applications on Azure. And you don't have to do the whole thing. Essentially, you are letting the SignalR service just take care of the clients, just take care of the SignalR bits. You can still host your ASP.NET stuff on your own, but just the SignalR part of your application, that you can let Azure host it, and then it knows of all of the clients that are connected. And obviously, this being Azure, you have infinite scalability. You have a little button that you can move back and forth, trying to control how many VMs you're using, how it's deployed. So it's really, really easy. And it's a RESTful API, so again, you can connect up to that service from any application, iOS, Android. IoT is really good if you're looking at kind of automation solutions. And again, automation is something that works really nicely with real-time apps like SignalR. OK, so this is, again, one of the Microsoft slides where think about the ammunition we have as developers. We have gRPC, we have SignalR, and all of these are frameworks that take away all of the pain that, I mean, I have written WebSockets connections by hand, and it's not fun. It's just a lot of work, right? And here are frameworks that take care of all of those pains for you, so you can focus on your application, and no matter what be the client type, you can connect up to an ASP.NET backend, and it scales very nicely if you are a little careful as to use a Redis backplane or use a SignalR service. All right, so what I wanted to do just is showcase a little bit of the power of some of these frameworks that abstract the network and the real-time benefits that you get. And beyond that, I mean, the world's up to us to change. And I'm going to stop maybe a few minutes early, but again, that's me on social media if you need to get hold of me. So let's go build amazing apps, and hopefully you enjoy the rest of Basta. And thank you, and I appreciate your time today. All right.